Hello everyone, my name is James and this is my Visual Basics project for my ABE 205 class. And what I chose to do was to create a user form that calculates the yearly cost of adjusting your air conditioner to your preferred temperature in every state using Newton's law of cooling and heating as seen in the title right here. In this video, I will first show how the program is used by going through everything step by step. And once that is done, I will go into the actual coding in the program and explain that in a little more detail. Okay, to start off, we got this little box of text right here that tells you to complete the program. Click on the first button labeled Step 1. So we're going to do that. When that's clicked, a user form pops up and asks you to select a state that you want to check the data for. What this does is that when you select a state, the collected temperature data for that state for every single day in 2013 will be displayed in this column right here labeled state. This will be the first step in using Newton's law of cooling and heating in order to calculate how much it's going to cost you to maintain your AC at whatever your preferred temperature is. Okay, so for this example, we're going to go with Arizona. And once we have that selected in the combo box, we're going to click Save and Accept. And as you can see, all of the recorded temperatures for Arizona for every single day from 2013 is now displayed in the state column. Okay, next we're going to click on the Step 2 button, and when we do that, another user form will pop up that's a little more involved than the previous one. Now, in order to use Newton's law of cooling and heating to figure out the costs for the AC, we need to first figure out a number called the K constant, and to put it simply, it's just a relationship between the outside temperature, your indoor temperature, and the time it would take for the indoor temperature to change. In this case, we picked Arizona, so we'll make the outside temperature 80 degrees Celsius. Your indoor temperature is kept at a nice, cool 70 degrees, and the amount of time it would take to increase the indoor temperature by 1 degree, we'll say it's 5 minutes. Now, this is all the data you need to calculate the K constant, which will be done once we click the Save and Accept or the Accept button. Next up, we need to figure out what your preferred temperature is, and we also need to select the same state that you chose in the previous user form. Me personally, I like it to be a nice, cool 75 degrees Celsius, and we chose Arizona in the first user form, so we gotta pick that again. Okay. Now, to make sure that everything we put in is correct, we'll click on the Accept button, and a message box will pop up to show you all the information you put in, and you can check that out to make sure that all the information you put in is what you want. We have the outdoor temperature at 80 degrees, indoors is 70. We said it takes 5 minutes to change the temperature. Our desired temperature is 75, and you can see right here, the K constant is calculated, which will be useful for the next part. And the state we chose was Arizona. That is correct. And if the above information is correct, click the Save and Accept button. So yes, everything is correct. So let's click this button. And as you can see right here, you have the K constant displayed in the third column, followed by the price it would take to change the recorded temperature for Arizona into your preferred temperature. For example, first day of the year, January 1st, 2013, for Arizona was 46 degrees. Your preferred temperature, we said, was 75 degrees. So it'll take about 1.7 pennies, which isn't a whole lot for a day, but that can add up throughout the entire year. As you can see right here, where the total cost of the adjustments will amount to roughly $19. If you want a little more detailed information as to which days of the year are pricier than others, then you can click on the Step 3 button, which will produce a graph. And as you can see on the graph, towards the roughly the beginning of the year and the end of the year, the prices are significantly higher than, say, the middle range, which kind of makes sense when you think about it. In the winter, the outside temperature is a lot colder, so if we're going by Newton's law of cooling and heating, it would take a little more time for the indoor temperature to increase to your preferred temperature. And more time using the AC means more money being spent on using the AC, so therefore higher costs. The last step isn't a necessary step, it just closes the graph in case you don't want it there for some reason. But that would be the entire program in use. This is how it is used to calculate your yearly costs of maintaining your ideal temperature in a given U.S. state using Newton's law of cooling and heating. Let's do another example. So let's go back to step 1, select the button, and once again we have the user form that tells us what state we want to pick. This time let's go or something a little warmer than Arizona, like here we go, Texas. So once we select Texas in the combo box, hit the save and accept button, and like before with the Arizona data, we now have the daily recorded temperatures from 2013 for Texas now in the state column. Alright, so now we go on to step 2 where we input the temperature data. And for this one, well, Texas is pretty hot, especially during the summer. So for the outside temperature, let's say it's, I don't know, 100 degrees Celsius. And the indoor temperature is kept at a nice 8 degrees. With the time to increase the temperature indoors by 1 degree Celsius, we'll say that's, I don't know, 4 minutes. Alright, once again, with all that data inputted in the first 3 text boxes, we now have all the information necessary to calculate the K constant. Once that's done, we move on to the final 2 boxes where we input our preferred temperature. Once again, I am a little more comfortable with 75 degrees, but let's go with 60. And once again, we need to select the same state that we've selected in the first user form in step 1. Texas, there we go. Now, click the accept button just to make sure that all the information is correct. The outdoor temperature is 100 degrees. That's good. Indoor is 80. We said it takes roughly 4 minutes for the indoor temperature to increase 1 degree. And the temperature we're looking for is 60 degrees. And, like I said before, the K constant in this particular situation is calculated and displayed right there. And yes, we are looking at Texas. That's all good. So now we hit the save and accept button. Alright, now let's take a closer look at the results. Now if we take a look at the first day of recorded temperatures for Texas, we see that we have 40 degrees Celsius. And to get that 40 degrees up to the 60 degrees that we're looking for, given the calculated K constant, we're looking at paying roughly 10 cents. Now, if you're curious as to why this is vastly different than our calculated Arizona price, keep in mind that every state has its own price for electricity use that depends on a multitude of factors, and thus we would have different calculations for every state. Once we have calculated all of the daily costs of maintaining that 60 degrees Celsius in our homes in Texas, we could then take a look at the yearly cost over here, which amounts to, whoa, $80. Okay, apparently everything's bigger in Texas, including the electric bill. Anyway, if you want more detailed information on which days are pricier than others, then once again, we can click on the Step 3 button, and it will produce a graph that will show us. Now, if we take a look at the graph, you'll notice that there is a slight increase in the average costs around the middle of the year, which would be the summertime, which would make sense. We're talking about one of the hottest states in the United States, And in order for the AC to combat that high temperatures, it would probably have to run a little bit longer, and thus it would probably cost a little bit more to get the home to your ideal temperature. Well, anyway, that's how the whole program works. I hope you enjoyed this presentation. Have a good day.